In my last report, I explained some technical details about addressing a silly way I was representing the data in my game that was causing incredible slowness when rendering 500,000 pixels in a dungeon view for the dungeon under my house, my second freshly squeezed entertainment project. If you've been following along, you know that the dungeon under my house will be a non-violent first-person dungeon crawler, and as a freshly squeezed entertainment project, it will be a polished, playable prototype that provides a complete entertainment experience. It will be freely available for desktop computers as well as mobile devices, with no ads, no in-app purchases, and no personal data tracking. Hello and welcome. My name is Gianfranco Berardi. My pronouns are he, him, his, and I encourage curiosity and support creativity through my solo indie game development studio, GB Games LLC. I'm really happy that you're here to join me in this indie game development journey. In this week's Freshly Squeezed Progress Report, you can see the link in the companion blog post in the description, I addressed some issues with the doors in the dungeon, and then I continued optimizing the dungeon rendering code. Things are much better, but while the rendering is now more or less handled in real time, I'm still not satisfied as there is still a noticeable slowdown when animating transitions in the dungeon view. I want to hit 60 frames per second. But first, let's talk about doors. I love these doors. When you open and close them, they act like real doors with hinges swinging out and in. If you're familiar with game development at all, you know that doors can be deceptively challenging to design and implement. Many games that implement raycasting like to have sliding doors or walls that pretend to be doors, mainly because they are easy to do. So I'm proud of my doors. I'm also designed these doors to prevent navigation. Depending on which direction you're facing, and depending on whether or not the door is open or closed, you will find your way blocked. Eventually, other entities you'll find in the dungeon will similarly find their way obstructed, and my goal is for the doors to be used sometimes as tools by the player to solve challenges. So the doors are great in terms of functionality, but what was wrong? The main problem was that in this particular view coming up, the door should look like it was obscuring the right side of the screen, but instead, it was rendering as if it was floating out in the middle of the viewport. My best understanding of what was happening is that the raycasting code was projecting out of the camera plane, and so while I normally would expect the door to intersect the view, the point of the plane was to not render anything behind it. So the rays were casting around to the other side of the door, and so I was rendering what was seen there. I tried various approaches, such as changing the field of view, but the only way doing so resulted in a door on the side obstructing your view also prevents you from seeing into the hallway next to you, and I didn't like losing the player's peripheral vision. So ultimately, to solve this problem without introducing new problems, I just made the doors bigger. Now they cross the entire grid cell, so instead of protruding out of the camera when open, they are seen from the side. I'm not happy with needing to make this change, as I like the look of the doors as they were before, but it seemed the least bad approach. Plus I learned that I liked how it looks when I changed from a field of view of 1 to 2/3, so there's at least that benefit that came out of this. Oh, and I finally fixed the lighting issue with the door over here on the side. It turned out that it was calculating the cell incorrectly when grabbing the lighting data, so it was grabbing lighting from outside the bounds of the dungeon. It doesn't do that anymore. Meanwhile, I'm still optimizing the general dungeon rendering code. I got pretty far with doing poor man's profiling, in which you interrupt the program running in the debugger and see which areas of the code most frequently seem to show up. But I finally decided to use an actual profiler, and when I visualized the results, I got some pretty charts that revealed some insights into my code. Namely, rendering the walls and doors is really fast, and the really slow part is rendering the ceiling and floor. Now I knew this fact intuitively before based on my previous debugger-based profiling, but I didn't realize how drastic it was. What this data tells me that there's no reason to try to optimize the wall or floor wall or thing rendering code anymore, as they aren't my main bottlenecks, and I won't see much improvement overall. And as the floor and ceiling code, they are pretty much mirrors of each other, so what's nice is I can make changes to one and see how it affects the performance relative to the other. Some of my changes were small yet impactful everywhere. For example, as I'm programming in C++, I found a few places where my code was inadvertently making temporary copies of small data structures, and I was able to eliminate the creation and destruction of those copies. But the other changes involved breaking up calculations so that part of them can be moved out of the inner loop, and even the outer loop. And while things are much better, and I can even feel the performance difference, I can tell that things are still too slow at times. I've made a number of improvements, and maybe I might find some more, but fundamentally my biggest bottleneck here is that I'm trying to iterate through 500,000 pixels. So my next optimization will be to try to reduce that number significantly. Currently I render the ceilings and floors, and then I render the walls on top. This means that each of the pixels in the viewport gets processed, and then most of them gets covered up. But what if I draw the walls first? Then I can detect the undrawn areas to fill in around the walls instead. I anticipate that it would cut down on the number of pixels to process dramatically, and since processing those individual pixels is the most expensive part according to my profiler data, that should help improve rendering the dungeon overall. Thanks for watching, and stay curious. Now, if you want to learn when I release the dungeon under my house, or about future freshly squeezed entertainment games I'm creating, then sign up for the GB Games Curiosities newsletter, and download full-color player's guides to my existing and future games for free. Again, check the links in the description.